When you develop a model, for example, of a manufacturing facility where the interest is to know how many products per hour can be produced, you cannot tell your stakeholder or your client that they will produce 100 products per hour as a result of your simulation model, because the simulation is stochastic, so you cannot really know the exact number. So what you do instead to communicate this is giving a range. So you will say that the average production per hour will be between 100 and 120 products per hour, with a confidence interval of 95%. To achieve this in AnyLogic, you need to do a MonteCarlo experiment. And the MonteCarlo experiment has the possibility to use replications. A replication is a set of, in this case, 10 simulation runs that are done with the same set of parameter values. And this is perfectly fine, but one of the features that AnyLogic shows here is that you can use a varying number of replications, which means that you want to run as many replications as you need in order to reach a confidence interval with a certain error percent. Unfortunately, this feature in particular doesn't work, and this is the reason why we created the library. In our experience, it is very important to run as many simulations that we need in order to reach this confidence interval. In general, we don't want to run too many simulation models in order to avoid wasting time, but we don't want to run too little simulation models as per not reaching a confidence that we want. And our library does exactly that the feature in AnyLogic doesn't do. So what we're going to do in this video is show a demo on how this works and how you can use the library. Let's get started.
Well, let's check this AnyLogic Cloud model. Here we are using the MonteCarlo library, where you can see the MonteCarlo interface first, having two plots that shows the current state of the MonteCarlo simulation. But let's take a look at what logic or model is running this MonteCarlo experiment. So click here on Simulation Model. It is about a motorcycle that has to do 10 laps on a closed circuit, but he has headwind that changes every time he ends a lap according to a distribution. The aim is to determine the average time it will take to complete the 10 laps, doing a minimum of 5 and a maximum of 2000 replications, with a confidence level of 95% and an error percentage of 0.05. In this case, it's not enough to run the model once or twice, because we have variability. So this is why MonteCarlo experiments are important, because we can handle in a better way the variability. So let's go back to the MonteCarlo view. Click here on Start, and we can see how the error percent varies over time, trending down, of course, due to having more replications, and as well the mean, the upper and lower bounds are converging here. And when the desired error percent is reached, no more replications are needed. That's why we only have 1400 replications done here. Okay, let's explore a little bit about this library. So you will see here in the palette the optimization library, and we have 3 agents here. The third one is MonteCarlo experiment, and this is the agent where all the stuff related to the MonteCarlo experiment is defined, including the minimum and maximum replications, confidence level, error percent, and the objective variable. I created here an instance of this agent, and you can see some parameters defined here. And as well, you can use parallel runs to speed up the results. This agent has also this presentation that you can see here, and this is the user interface when you run the simulation. And of course, you can click here on this Exports Results button to know the values at the end of the MonteCarlo simulation.
The MonteCarlo library is really a part of an optimization library that we created, and the MonteCarlo is just a byproduct of it. And we will discuss the optimization library in another video. See you soon.